7 minutes. That's how long it took for one research paper to force the biggest security company on the internet to tear up its own timeline. Google's quantum AI team just confirmed something scientists spent 30 years saying was impossible. And while the world was busy scrolling, the people who actually protect your data quietly hit the panic button. This is not a rumor. This is not a leak. This is published, peer-reviewed, and verified. And once you understand what Google's machine just did and what it means for every password, every bank account, and every secret on Earth, you will not look at your phone the same way again. Let's start with the question nobody in the mainstream media is asking. Why did Google, a company that makes its money from advertising, suddenly announce a hard deadline to rebuild the security of its entire global infrastructure? Not a suggestion, not a roadmap, a deadline. In late March 2026, Google announced a timeline to secure its systems against quantum computers by 2029, a full 6C, years before the official government deadline of 2035 set by the U.S. National Institute of Standards and Technology. Think about what that means. The most data-rich corporation in human history looked at its own research and decided the official government timeline was too slow. Companies do not voluntarily spend billions rebuilding their security 6 years early unless they know something. And Google knows something, because Google built the thing. To understand what just happened, you have to go back and watch the pattern. Because this was never a single event. It was a sequence, a staircase, and each step was bigger than the last. In 2019, Google demonstrated that its quantum computer could solve a problem that would take the fastest classical supercomputer thousands of years. The world shrugged. It was called a stunt, a laboratory trick with no real use. Then came the second step. In late 2024, Google's new quantum chip, called Willow, showed how to dramatically suppress errors, solving a problem that had challenged scientists for nearly 30 years. Read that again. 30 years. An entire generation of physicists said quantum computers would always drown in their own noise, that the errors would multiply faster than anyone could fix them. Willow proved them wrong, and that was only step 2. Because here is where everything changes. Google then published research in the journal Nature demonstrating, for the first time in history, that a quantum computer successfully ran a verifiable algorithm on real hardware, outperforming even the fastest classical supercomputers by a factor of 13,000. 13,000 times faster. And notice the word that matters most in that sentence. Verifiable. Every previous quantum milestone had a weakness. Skeptics could always say the result couldn't be independently checked, that maybe a clever classical computer could catch up one day. Not this time. The algorithm, which Google calls quantum echoes, produced results that can be confirmed, and it can compute the structure of a molecule, opening a path toward real-world applications. This is the moment the argument ended. This is the moment quantum computing stopped being a physics experiment and became a weapon-grade capability, and almost nobody outside the field understood what they were looking at. But here's where it gets worse, or better, depending on which side of history you're standing on. In a companion experiment, Google demonstrated a technique it describes as a molecular ruler, using data from nuclear magnetic resonance to measure distances, inside molecules beyond what today's methods can reach. That sounds academic until you translate it. A machine that can see inside molecules with impossible precision is a machine that can design drugs, engineer materials, and model chemistry that no supercomputer on Earth can touch. The nation or corporation that controls that capability doesn't just win a market. It wins every market built on chemistry, medicine, and material science, which is to say, most of the modern economy. The real story is not that Google built a faster computer. The real story is that Google opened a door, and behind that door is everything. And then, in the spring of 2026, the tone changed. It stopped being about discovery. It started being about threat. Google quantum AI researchers published a paper outlining a significantly more efficient implementation of Shor's algorithm. The quantum method, capable of breaking the elliptic curve cryptography that underpins Bitcoin and Ethereum. Let me put that in plain language. Shor's algorithm is the mathematical skeleton key of the quantum age, the procedure that, given a powerful enough quantum machine, can crack the encryption protecting almost everything digital. For decades, the comfort blanket was that you'd need an absurd, impossibly large quantum computer to run it. Google's own researchers just showed the requirements are dramatically smaller than the world assumed. The advance could sharply reduce the resources needed to crack private keys, potentially pulling forward the timeline for what experts call Q-Day, the day quantum computers defeat modern encryption. The reaction inside the industry was not calm. One prominent venture capitalist, Nick Carter, compared the quantum threat to the Manhattan Project, the secret program that produced nuclear weapons, saying the stakes are of a similar scale. Sit with that comparison for a second. People who move billions of dollars for a living are reaching for nuclear metaphors. A managing partner at the investment firm Dragonfly warned that quantum machines capable of breaking widely used cryptography could arrive sooner than anyone expected, pointing to estimates that a sufficiently powerful system could break the keys securing crypto wallets within minutes. Minutes, not years of grinding computation. Minutes. Another executive argued this destroys the old assumption that only dormant, forgotten wallets were at risk, because if keys can be cracked that fast, attackers could theoretically intercept transactions while they're still in flight. Think about what that means. The window between you clicking send and the network confirming it becomes an attack surface. Now, the responsible voices urged caution, and they deserve to be heard. An Ethereum researcher called the publication monumental, but stressed the results need further scrutiny, estimating a small but meaningful chance that quantum computers could break elliptic curve keys by the early 2030s. Small but meaningful. In intelligence work, that phrase is a fire alarm, because when the downside is the collapse of digital trust itself, small but meaningful is not reassurance. It's a countdown with an unknown number on the clock. And this is where the story leaves Google's laboratory and enters your life. Because of a strategy that intelligence agencies have quietly warned about for years. It's called harvest now, decrypt later. Adversaries are stealing encrypted data today and simply storing it, waiting for the quantum machines of the near future to crack it open. Your encrypted messages, medical records, government cables, corporate secrets, military communications, all of it can be vacuumed up right now, sitting in vast data centers like sealed envelopes, waiting for the letter opener to be invented. Google just demonstrated the letter opener is closer than anyone admitted, which means the theft has already happened. The only question is when the envelopes get opened. The proof that serious people believe this is not in what they say, it's in what they do. And what they did next tells you everything. Cloudflare, the cybersecurity company that protects a significant fraction of the entire internet, announced it was accelerating its deadline to prepare for quantum computers to 2029, with one of its researchers openly calling the new research a real shock and admitting they'd need to speed up their efforts considerably. Companies like Cloudflare do not use the word shock in public. Their entire business is projecting calm. When the people paid to be unshakable start moving their own deadlines forward by years, you are not watching a press cycle. You are watching a controlled evacuation. But here's the twist most people completely missed, and it might be the most important part of this entire story. The breakthrough wasn't achieved by human minds alone. A parallel paper from a startup called Oratomic, founded by researchers with ties to Google's own quantum program, relied on artificial intelligence to develop its algorithm, with one author stating flatly that there is no question AI accelerated the work. Read that again. AI is now designing the algorithms that will break the encryption protecting the world, including, ironically, the encryption protecting AI companies themselves. One of the paper's co-founders put it bluntly, people who understand the field will realize it's coming, and the world, in his view, is not prepared. Two exponential technologies, artificial intelligence and quantum computing, have started feeding each other, and exponential curves stacked on exponential curves do not give you warnings. They give you surprises. Google saw this feedback loop forming and moved fast. In early March 2026, the company posted a job opening for a quantum researcher to develop AI-based discovery pipelines, and days later announced a new internal atomic quantum computing initiative. This was not routine hiring. This was a company racing to institutionalize a discovery method before its competitors and before its own former employees beat it to the punch. Because in this race, second place doesn't get silver. Second place gets to live in a world where someone else holds the keys. And that brings us to the strategic decision that reveals Google's true assessment of where this is heading. For more than a decade, Google bet everything on one type of quantum hardware. Superconducting circuits, tiny loops of metal cooled to temperatures colder than deep space. Then, without warning, the doctrine changed. In March 2026, Google Quantum AI announced it was expanding beyond superconducting qubits to add an entirely second technology, neutral atom quantum computing, positioning the two approaches as complementary weapons against different classes of problems. The head of the program explained the logic in a single sentence. Superconducting processors are easier to scale in circuit depth, while neutral atoms are easier to scale in raw qubit count, and investing in both means delivering on the mission sooner. Translation from expert jargon into strategy, Google is no longer trying to prove quantum computing works. Google has transitioned to figuring out how it can be scaled, engineered, and deployed. That is the language of industrialization. That is what a company does when it believes the finish line is visible. This is not chaos. This is strategy. And it's a two-front strategy, because while one arm of Google's quantum program is racing toward machines that threaten encryption, the other arm is racing toward machines that could reshape medicine and energy. In May 2026, Google committed $10 million to 5 universities under a program called Replica, exploring how quantum computing, quantum sensing, and AI could advance biological and medical research, including molecular simulation and quantum sensors capable of observing biological activity with greater precision than existing tools. One target the company highlighted, the P450 enzyme, which governs how the human body metabolizes drugs, a molecular system that quantum simulation could eventually crack open for pharmaceutical development. The same class of machine that can shatter a Bitcoin wallet can also design the drug that saves your life. That duality is the entire story of this technology. It is the most double-edged sword humanity has ever forged. The economic stakes go even deeper than medicine. Analysts point to the energy sector as a primary beneficiary, because if quantum simulation can replicate how bacteria pull nitrogen from the air at room temperature, the world could reduce global energy consumption by roughly 2%, the amount currently burned just to manufacture fertilizer. 2% of global energy from one solved chemistry problem. Now multiply that logic across battery materials, carbon capture, superconductors, and industrial catalysts, and you begin to see why the world's most powerful governments and corporations treat this technology as a matter of national survival rather than corporate competition. The pressure is already reshaping global finance, with breakthroughs forcing the financial sector under G7 roadmaps to mandate post-quantum cryptography by the end of 2030. And Google is not running this race alone, which makes the situation more volatile, not less. IBM has pursued the opposite philosophy, a scale-out approach built on modular architectures, and by May 2026 had demonstrated the ability to interconnect 4 of its Flamingo processors into a roughly 4,000 qubit modular system operating as a single logical unit. Google, by contrast, focused on precision, proving in early 2026 that adding more physical qubits to its error-correcting code actually decreases the overall error rate. 2 giants, 2 philosophies, 1 destination. And when 2 of the largest corporations on Earth are sprinting toward the same cliff-edge capability from different directions, the timeline doesn't stretch, it compresses. Both companies are now even using AI models to monitor and calibrate their quantum processors in real time, predicting noise before it happens, and adjusting the system to compensate. The machines are helping build the machines. Let that sink in. So where does the countdown actually stand? Here is the honest, unvarnished picture, because this briefing deals in reality, not hype. Today's quantum computers cannot yet break your bank account. Current machines remain too small to be dangerous, but a 2025 survey of experts found a 39% chance that this changes within the next decade, as the hardware grows and the algorithms become efficient enough to run on ever smaller machines. 39%. Would you board a plane with a 39% chance of a catastrophic event? Would you build a civilization's entire financial and communications infrastructure on those odds? Because that is exactly what we have done. And the new results from Google and its rivals, according to multiple quantum computing experts, could significantly shorten the development time of a quantum computer that threatens encryption. The 39% was calculated before this breakthrough. Whatever the real number is now, it is not lower. There are legitimate scientific brakes on the panic, and intellectual honesty demands we name them. The most alarming recent paper has not yet completed peer review, and researchers like Princeton's Jeff Thompson note that many of its underlying assumptions remain untested. The machines still make errors. The engineering challenges between here and Q-Day are brutal. Thousands of qubits must be woven into fault-tolerant systems, and Google itself says its next hurdle is milestone 3 on its hardware roadmap, creating a long-lived logical qubit. This will not happen tomorrow morning. But here's the thing about the history of this field. Every single time the experts said a barrier would hold for decades, it fell in years. The error correction problem was supposed to be nearly unsolvable. It fell in 2024. Verifiable quantum advantage was supposed to be far away. It fell within a year. The pattern is not that the skeptics are wrong about the difficulty. The pattern is that they are wrong about the speed, which brings us back to where we started, to the question the mainstream coverage never asks. Why 2029? Why did Google pick that specific year to finish rebuilding its own defenses? Companies set deadlines based on threat models, and threat models are built from the most classified thing an organization possesses, what it privately believes about the future. Google's public research says quantum machines that threaten encryption are years away. Google's private behavior says the company wants its shields up in 3. When the words and the actions of the world's most informed player diverge, intelligence analysts have a rule: watch the actions. And the actions? The accelerated deadlines, the doubled hardware programs, The AI discovery pipelines, the emergency migrations at Cloudflare, the warning from a Cloudflare researcher that a quantum computer arriving before the world transitions to post-quantum encryption could unleash data leaks, extortion, and businesses being taken offline, leaving almost every system in the world vulnerable to a quantum attacker. The actions are screaming. So here's what you're left with. Somewhere in a laboratory cooled to a temperature colder than the void between galaxies, a chip the size of your palm just outran every supercomputer humanity has ever built by a factor of 13,000, and proved it. The encryption protecting your money, your messages, and your government's secrets now has an expiration date that nobody can read, only estimate. The data has already been stolen and stored, waiting. The world's most powerful corporations have quietly moved their own doomsday preparation deadlines forward by 6 years. And artificial intelligence, the other revolution of our lifetime, has begun designing the very algorithms that will decide who holds the keys when the old locks fail. The official story says there is still time. The official story says the transition will be orderly. The standards will be ready. The migration will happen before the machines arrive. But the official story was also written before a quantum chip ran a verifiable algorithm 13,000 times faster than anything on Earth. So ask yourself the questions that actually matter. If the world's biggest technology company believes the wall falls by 2029, what do the intelligence agencies with even more resources believe? If the data being harvested today gets unlocked tomorrow, whose secrets get read first? And who does the reading? And if the last 3 impossible barriers each fell years ahead of schedule, what happens when the 4th one falls? Not in a lab announcement, but in silence, in a facility whose existence we only learn about after the locks have already been opened. The countdown is running. The only thing we don't know is how much time is left on the clock.